All right. So for this one, it says in the following diagram, we have a picture. LQ is 5 centimeters. So LQ is going to be 5. PQ is 6. So that means this segment over here is going to be 6. Find MP and measure of MPQ. So MP, so we have a tangent line here. That means we have a right angle. And then we also have a radius. So if this is 5, that means this is also going to be 5. So my whole diameter is going to be 10. So if I take out this triangle part over here, where this is my M, my P, and my Q, I got MQ is 10, PQ is 6, and I want to find MP. So I do 6 squared plus, or x squared plus 6 squared equals 10 squared. You get x squared plus 36 equals 100. Minus the 36 from both sides, I get x squared equals 64. And then we're just going to square root and get x equals 8. So that means my MP is going to equal 8. Then my measure of MQP is over here. So that's that section. So what I could do in order to find that section is basically use SOHCAHTOA or something like that because we have a right triangle. So if I use SOHCAHTOA, technically I can use the 8 if I want. I like using the things that they gave me. So they gave me adjacent and hypotenuse. So A and H go cosine. So I'm going to do cosine of the angle, which I don't know what that is. We'll say Y equal, or actually we'll just name that Q. Since they gave me a Q anyway right there. Q equals my adjacent over my hypotenuse. Now in order to get that Q by itself, I'm going to do cos inverse of both sides. So cos inverse of 6 over 10. Let's grab that. And we get 53.1. So our Q is 53.1 degrees. Next one, triangle LMN is inscribed in a circle with diameter of LM. The inscribed angle is N. The measure of the vertex is L is 37 degrees. Find the measure of arc MN. Okay, so we got a circle. Let's draw out a circle here. Wow, that is not a circle. Okay, restart. We got a circle. A little bit better. We have a diameter of LM. Okay, so L to M. Then we have an inscribed angle. And that inscribed angle is N. So N is like over here somewhere on the circle. The angle measure is at the vertex of L is 37 degrees. All right, so we got something like that. Find the measure of arc MN. All right. So for this one, all we want to do is basically double that 37, and then we're going to find this arc right here. So 37, and I double that, is going to be 74 degrees. So that's going to be arc MN. And then finally, Reggie draws a triangle inside of a circle. He labels the vertices CDE with the diameter of CD on the inscribed angle at E. He draws the length of CD 14 centimeters long and CE is 8 centimeters long. What will be the approximate measure of angle D? All right, so again, we're going to draw a circle out. Our diameter is CD. So we're going to have C to D be our diameter. E is going to be our inscribed angle somewhere, so that's going to be an edge. Then he draws the length of CD 14 centimeters long, and CE is going to be 8 centimeters. Like that. What will be the approximate angle measure of D? So right here, I know that because we're on this angle, and then this section over here is 180 degrees because we're opening up to half the circle. That means this is going to be a 90-degree angle right there, which is going to be helpful. Because if I have a 90-degree angle, this is angle E. We'll say C is up here, D is over here. This hypotenuse is 14. I'm trying to find angle D. That means this is going to be opposite hypotenuse. And opposite hypotenuse go with SOHCAHTOA, S. So I can set this up as sine of my angle D equals my opposite over my hypotenuse. Do sine inverse to both sides to get rid of that sine. And that means angle D is going to equal sine inverse of 8 over 14, which is 34.9. So they said approximate, so we'll say about 35 degrees. So angle D is going to be 35 degrees.